Okay, here we go. Let's get this done quick so you maybe get a chance to work on this stuff a little bit. So here's the last assignment, 5 problems. I'll take care of 2 of those today because one of them isn't what I thought it was when I assigned it. So we'll go through that. The last one we'll go through together. Okay, this one right here, all I can say about this one, I think I've mentioned this, is you gotta be really careful, right? This one, it gives you this information about these 6 airplanes, but you gotta always, when you're dealing with graphing, plotting data points, or even just making a graph of a function, you always want to pay careful attention to what are the quantities on the x and y axes, right? So what's our x variable in this case? Length, okay. And the y variable is? Okay, what a lot of people were doing, if they missed either part of the problem or all of the problem, was at least, like, even if it was just like 1 or 2 times, people mixed up these coordinates sometimes. Which one, like on this first spot for the 737, what should my ordered pair look like? What comma what? The x goes first, right? It goes x comma y when I think of an ordered pair. Yeah, good. So the ordered pair has to be in that form. And for the first point, we got to make sure we're taking the length as the x coordinate and the wingspan as the y coordinate. So the first coordinate, the first point would have coordinates 130, 113. That make sense? Okay, and so when I want to add that point, you got to be kind of careful. If I'm going over to 130, that's halfway in between 120. Everybody see that? Make that a little bigger. So I got to be halfway between 120 and 140. So right there. And then I got to go up to 113. Well, that's not very convenient. It goes from a y value of 100 to a y value of 120. So what do? Yeah, I got to estimate. Yeah, it's going to be, so 113 is going to be just a little bit more than halfway between 110 and 120, right? So it's going to be, I don't know, right about there maybe. That makes sense? You have to be fairly close for it to give you credit. Okay? So you're going to add all those points and then answer some questions. Let's look at, real quick, number 2, really simple. Number 2 is not asking you to do very much at all. Number 2 is giving you a model and just wants you to use it. So what's this saying here? The model A equals 0.25t plus 29 represents the median age A of females in the United States as a function of the year. The time, which is going to be the year since 1970. So if I wanted to put in a value of t corresponding to 1973, what number would I put in? In this, say it again? No, if I want to go, so time t is going to be the number of years since 1970. So 1973, t would have what value? How many years after 1970 is 1973? 3, yeah, so it'd be 3, right? Exactly, right. So I'd put in 0.25 times 3 plus 29 would predict for me in 1973 what the median age of females in the United States was. Okay, does that make sense? All right? So then of those variables, now we got to get some practice at this. Let me write this a little bigger so you can see it. Here's my function. A equals 0.25t plus 29. So which is my input variable here? Oh, what's your variables? What do you think? What's my input variable? T is, right. How come? You're right. Why? Why is t the input variable? Maybe an easier question is, why would A be the output variable? Okay, because it's like y equals something, right? It's A equals some equation involving t's, right? The output of plugging a value in for t and calculating a number, right, is going to be the value of A. The number that's by itself equal to the expression is almost always going to be the output variable, right? Because what we want to be able to do is take a value of our input variable, plug it in, and see what we get for the output, right? Does that make sense? So t is like x, that's our input variable, and a is like y. Okay? Sometimes we even like to write this, and you've seen it this way. How do I say that? How do I say this part right here? Okay, it'd be like f of x, but this time it's a of t. Meaning a is the output variable, a is a function of t. I'm inputting those kinds of values and getting back those kind, right? Okay. So then all I've got to do here is just figure out what value to plug in for t and plug it in, right? In 2002, what's going to be the value of t? What's it going to be? 2002. I'm measuring t in years since 1970. So how would I find that? Subtractive, sure. 2002 minus 1970 is what? 32. So I'm going to put in a value of 32 into this equation and just see what I get. 0.25 times 32. You can tell me what that is. 0.25 times something, what's that really doing? Taking a quarter of it. Same thing as dividing by 4, right? So what's 1/4 or 0.25 of 32? 8 plus 29? 37. Right? So we would have expected in 2002, we would have expected that the median age of a female in the United States was 37. Okay? All right, moving on. You can finish that one up. Yours is probably different. Okay, what about this one though? This is the one that I think I want to maybe rehearse how we do this one. Because there's a lot of steps involved in this. So this one here is not so easy. This time, they're asking us to create the model by using linear regression. So this is where we got to use the calculators and go through that process, right? So you get to talk me through the process here. Here's my calculator. Whoops. Okay, so what do I do? What do I do with this? If I want to use that data and I want to create a regressional model, I guess before I even mess with the calculator, I've got to know what's my independent or my input variable and what's my output variable. So let's read this together. Anthropologists who study skeletal remains can predict a woman's height just from the length of her humerus. So that's just this bone right here, right, between your elbow and your shoulder. The table gives data for humerus length and overall height for various women. Okay, so they're giving us what, 8 data points. Okay, and we're going to try to come up with a relationship then, a linear model that relates humerus length to height. Which one do you think is going to be my output variable here, the dependent variable? Abel, what do you think? Height. Yeah, sure. Because that's what we're trying to approximate. We're trying to estimate, right? We have this bone here. We're going to measure the length of the bone, and then by inputting that value, our model is going to be able to output the predicted height of the person, right? That make sense? So the x variable, and a lot of times we'll talk in terms of x and y. We might change those variables to match what the words are that we're using, but really we could always make them x and y if we wanted to. So this is going to be like my x or my input variable, and that's going to be like my y or my output variable, right? Okay, and then we want to come up with a linear regression model right here. We're going to fill in the blanks. Now, normally we would think about that as being y equals mx plus b, but for us, instead of y, we have h, and instead of x, we have l. But this is still just going to be my slope, my rate of change, and this is going to be the starting value or the y-intercept, right? Okay, so now, how do we get that stuff? Yeah, exactly what we do. So let's go into our calculators. Now, where do I go first on my calculator? Stat. Okay, this is a statistics prediction. So we go to the statistics screen. Now where? 1, or enter. We're going to go edit. Good. And there it is. Okay, I've already got all the data in there. If you want to put it in there, go ahead. Stat is like right in almost the exact middle of the calculators, right there. Okay? So, okay, yeah, so what happens, remind us real quick, what happens if you want to clear some old data out of there? What do?
You go to L1, press clear.
Good. You go to L1, press clear, enter, and it'll clear all the data out from that column. Okay? Good. Okay, everybody got it in? Put the data in there if you want to. What's next then? So, two things, right? We want to be able to do, we talked about how to do a scatter plot. We don't really have to do it here, but let's just remind ourselves real quick how we do that. If I wanted to do a scatter plot of that data, it's really simple. All I've got to do is two things. What do I have to do? Got to go to y equals and do what? Got to clear any of the equations that I had from a previous problem. But then what do I need to turn on? Got to turn on plot 1, right? I just go up and highlight plot 1 to turn it on. And then how do I let the calculator do all the hard work for me of setting up the XY plane, setting up the coordinate axes so I can see the data on my screen? Zoom 9. Very good. Zoom stat. Zoom 9. And you should see that. Everybody should look exactly the same. Right? Okay, there it is. Okay, now the next part here, all they want in the next part is they want to know what is the linear regression model. So now we've got to go back into the stat screen and we've got to move away from the edit stuff and we've got to move over and let the calculator find the best fit line. How do we do that? Stat what? Good. Stat. Then I'll hit the right arrow to go to calc. So we'll say stat calc 4. Stat calc 4. And there it is. That's linear regression. Everybody should look like that. If you go down, if all we want is the equation, we can just go down and hit calculate and it's going to spit it out for us. So what does this mean then? So the calculator is telling me that the model of the form y equals ax plus b is this. These are the values of a and b that I plug in. Now that's not exactly the way that we want it written for our problem. For our problem, we have to go from y equals ax plus b to our situation. Well, our situation is h equals, because y becomes h, blank, which we'll call a, times, instead of x, what do we have? L plus b, right? So we're just going to plug in the numbers for a and b, and that's our model, right? It tells us to round to the, what, 2 decimal places? So what do we get then? So what do we get? H equals, what's my value? What's the coefficient of x or L going to be? What's the slope? 2.75. Good. Okay. And then what's B? 71.97. Okay. Good. Okay. There's our model. What's the shortest length of a humerus in the given table? You just look at the data table up there and tell me. What's the shortest?
25.
25. So that's our smallest input value, right? What's the longest input value? 39. So what's our domain? Yeah, it's going to be all the values, the set. What does this mean down here? The set of L such that L is greater than or equal to, what's my bottom value? 25. Greater than or equal to 25 and less than or equal to 39. Right? Go ahead, check. that what I do?
Yeah.
Yeah, okay. So we got that. Now we go down to the next part. Okay, so now the next part, predict the woman's height from a humerus that is 37 centimeters long. So what do we do? When L equals 37, how am I going to use that model to calculate the height? Plug it, well, yeah, plug it in, right? I've got this model up here now. Now I'm just going to take the value of 37 and that I'm going to plug that in for L, right? So all I've got to do is multiply 2.75 times 37, get an answer, and then add 71.97 to that. And what do I get if I do? Somebody? So her height says rounded to the nearest centimeter.
173.72.
So it's 173.72. So if I round that to the nearest centimeter, that would be 174. Yeah, because we're measuring in centimeters. Okay. Oh, whoops. 173 point what?
72.
So rounded to the nearest centimeter would be 174. Okay. Okay, so what about this next part then? Because 37, is 37 in the domain?
No.
It's not? What's our domain go from?
25 to 39.
Oh, it does.
So it is then, right? So 37 is inside the domain. This prediction is what? What's the difference? I can't remember. I don't know if we got to this or not. Interpolation versus extrapolation. What's the difference, you know?
Extrapolation.
Enters between.
Outside the domain.
Okay, good. Extrapolation means we're going to make a guess outside of the scope of our data, right? Interpolation means we're going to take a value within our data set somewhere, inside our domain, and make a prediction. Which one do you think is probably usually more accurate?
Interpolation.
Interpolation, yeah. Good. Okay, does that make sense? Okay, last one we'll do together. Get this out of the way. And then, we have any time? Oh, maybe if we hurry. Okay, so this is, I don't think this is that big a deal personally, but you might see this again in a math class. I think it's way, way better to do this stuff on a calculator, to do use regression to find the best fit line. But you might even get a question like this on the Smarter Balanced Assessment or something too. So let's take a look at this. We want to look at how we could obtain a linear model for a data set without using a graphing calculator. So what can we do? After making a scatter plot of the data, we would want to draw what kind of a line here? What's the line going to do? That's going to pass as, what do you think? Far from or close to the data points? Yeah, good. As close to all the data points as possible, right? Then if we want to find the equation of that line, how do we find the equation of a line? We've got to pick two convenient points and find what? The slope. First we're going to find the slope. So we're going to use 2 points on the line to calculate the slope. And then what happens once we've got, let's say, here's an example. Let's say that our line goes through the points, I don't know, let's say it goes through the point 1, 2, and 5, 13. Is that a good one? That's bad. How about 5? 18. Okay. What's our slope going to be? And we would have this drawn, so it'd be easier for us to do. But if this were drawn on an XY plane, here's one of my points down here with coordinates 1, 2. Here's another point over here with coordinates 5, 18. How do I find slope? Rise over run and make a slope triangle, right? So I could just go like this. I would be rising by how much?
4.
No, hang on. Rising by.
16.
How'd you get that?
18 minus 3.
Yeah, okay, because the y values are going from 2 to 18, right? So 18 minus 2 is 16. So I'm rising by plus 16. How much am I running by? That's going to be a horizontal or an x value. 4. And so then my slope would just be rise over run. So 16 over 4 is what?
Just kidding, 4.
4, there we go. So m is 4. Okay, so now, here's the other part I just want to quickly review, because I just have a feeling you probably haven't done this in a while. So if I want to come up with the equation of this thing, then look at the stuff that I have. I want to fill in the blanks for y equals mx plus b. I know m. M is 4, right? Oops. 4 I can plug in there. What about x and y? Do I know values of x and y that I could plug into that equation also?
Yes.
Yeah, what's one possibility? You're right. I could plug in, I could use this point, couldn't I?
Yeah.
Because that's just an x and a y value, right? So I could plug in, 1 goes in for x. Everybody with me on this? 1 goes in for x and 2 goes in for y. That would work. What else could I do?
Probably.
Yeah, I could put 5 in for x and 18 in for y. They would both work. Which one's probably easier? Yeah, use the smaller numbers, 1 and 2. Okay, but if I do that stuff, what's the only, in this equation down here, what's the only part of this equation that I don't have a value for?
B.
B. If B is the only thing I don't have a value for, I can just solve for it, right? That's easy. So what do we get if we do that? If we do that, we get, when we say y was 2 equals m was 4, x was 1. So what am I going to get? 2 equals 4 plus b, right? What's the one thing I would have to do to get the b by itself?
-4, it's -2.
Yeah, subtract 4 from both sides. Right, so I get b equals -2. Now I got it. I know what b is. I know what m is. M is 4, right? And so now I can go back to my y equals mx plus b, and I could rewrite that as y equals 4 x minus 2, right?
Yep.
Got it?
Yep.
Okay, I think we're good.
To the left.
Is it worth it?
I think it's about 5 minutes.
Can you tell me my stuff?
Yeah. Does anybody need their, just got a bunch of, bring the calculators up. If you need your passwords or usernames, come on up, I'll give them to you.
Can you just tell me?
Yeah.
I'll write it down.
Yep.